Hey everyone, I'm back with another problem on the InterviewBit series for the topic arrays. So the problem today is move zeros. So you are given an integer array A, you need to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. Right. Note that you must do this in place without making a copy of this array, and the size of the array can range from 1 to 10 to the power 5. Okay, let's look at a test case to make it more clear. So what you need to do here is you need to move all the zeros to the end of the array. So let's first do that. So if I move the zeros to the end, there are two zeros and I've moved them to the end. Now the second thing they want us to do is you need to maintain or preserve the relative order of the non-zero elements. So initially it was 1, 3 and 12. You need to maintain it. It would be like 1, 3 and 12. Okay, and 0, 0. Okay, so this would be the answer. Okay, understood? Okay, so one quick brute force approach which comes to my mind is uh what if I can have an array? Let's have an empty array which is an answer. Okay, so I'll push all the non-zero elements first in the answer, and then I can count the number of zeros in my original array. And after pushing all the non-zero elements, I'll at the end, based on my count of zeros, I can push the zeros, right? What I'm trying to say is let's maintain a variable called count 0, which would be equal to 0. Right, let's iterate from the start. So if it's a 0, then you increment it, becomes 1. If it's a non-zero element, you push it to the answer array. Okay, it's 0 again, you increment the count. It's a non-zero element, 3, you push it to the answer. Again, it's a non-zero element, you push it to the answer. At the end of the iteration, what you want to do is, if this variable is non-zero, then you need to add this number of zeros at the end. So since it's 2, we can add two more zeros at the end to make it 1, 3, 12, 0, 0. Right, so this is the answer. But what is the time complexity for this solution? It is O of n. But if you look at the space, we are using an external answer array to store this. So it also has a linear space or O of n. But we have also been mentioned here that you must do this in place without making a copy of the array. Right, we need to do it in place. So how do you think about that? So whenever there is a mention about in place and you need to move something here and there, the only way to do it is swapping, by swapping. Okay, by swapping two elements, right? So when you need to swap, you always think about pointers, right? You always think about pointers since you need to swap. So one thing which we need to note here is moving zeros to the end is same as moving the non-zero element to the start. Agreed? Agreed on that? Moving zeros to the end is same as moving the non-zero elements to the start, but while preserving the order. Right? Great. So what I can do here is I can maintain a pointer called start. Okay, let's maintain a variable or a pointer called start at the start of the array, and its value would be 0, which denotes the index of this array. Right, now we can start iterating from the array, and we can check if it is a 0. If it's a 0, then do nothing, just move on, right? If it is a non-zero element, so what I told you at the start is moving zeros at the end is same as moving the non-zeros to the front. Okay, so if it's a non-zero element, you move it to the front. So now I is equals to 1. So what I can do is I can actually swap the 0 and 1. So this array becomes 1, 0, 0, 3 and 12. Okay, got it? And when you swap an element, when you find a non-zero element and you swap it, you actually increment the start. You increment the start. Why would you increment the start? To denote that the first zeros lie at this index. Okay, so now my actual start would be pointing at this and my next index would be here. Okay, so this is again a zeroth element. So I'll move forward to look for my next non-zero element, which is 3. And since it's a non-zero, we'll swap this current I with this start. Okay, with this start. Perfect. Now the array becomes 1, 3, 0, 0, 12. And when you swap it, you also increment the start. So the start becomes 2 now. So my start is pointing at this index, and my I was initially at this. Okay, so I'll search for my next non-zero element. I'll come over here and this is 12. So I'll try to swap these two again. So now my final array becomes 1, 3, 12, 0, 0. Okay, now my start becomes 3. Okay, so the start would be somewhere here, but I don't have an element now. And you can see that the array is exactly like we wanted it to be. All the zeros have been moved towards the end and all the non-zero elements have been moved towards the front, right? So it was just a straight up implementation problem. And here the time complexity is O of n and the space complexity is constant. We are not using any external array to store or anything, so it would be this. So this is the optimal solution. Now let's move on to the coding part. Now let's code it up real quick. So we are given this array. First I can get the size of the array, which would be a dot size. Now let's maintain a variable called start, which would denote the starting index where the first zero occurs. Okay, so I'll start from the front and I'll check if my current element is a non-zero element. If it's a non-zero element, then what I need to do is I need to swap it with the start and I can increment the start. Okay, so this was really it, and you can return a at the end. So let's run it. So the trivial cases are passed. We'll submit it. No. Yeah, so it is accepted. There comes the Superman. So I hope you guys understood the solution. I'll meet you guys in the next video. Till then, take care. Okay, chalo, bye.